Hello, everyone. Good evening. Thank you so much for continuing to stay at the very end of 3 days. So, we'll have a short talk on compute for AI. And I'm Arun Subramaniyan. I lead the cloud and AI strategy for Intel. Right? So, really quickly, what enables AI of any levels? Today, we'll be talking a lot about this AI's particular type of AI called generative AI. But then, really, it's three levels of the stack. The bottommost level is the focus of the conversation today, which we call compute. Then the one after that is software that makes the compute work. And then there is all the applications that are built on top of that software that actually get you to your outcomes, right? And it's about solving the world's most demanding challenges with AI through compute, right? And it's not necessarily a new thing that is going on, but if you look at how do you even measure compute, right? You hear about these terms like flops, right? Think of a flop as just a unit of compute. How many calculations can you perform in 1 second is a flop. Floating point operations per second, right? Now, if you compare across all of the different devices that we are used to, a mobile device somewhere between zero point 0.5 to 2 teraflops, that is 10 to the 12 zeros after that number. Laptops 1 to 2, server grade CPUs, you're starting to get into 3 to 5. And then this new class of compute that is called accelerated computing, which is graphics processing units or accelerators such as application specific integrated circuits, things of that nature have a big jump, right? So that's like about 40 to 65 teraflops per chip, right? Now, it's one way to easily compare all of them because you can easily calculate what the calculations are. But then not all of them are really made equal because the CPU is made so that it can calculate a lot of complicated computations. So it can check email, you can do video streaming, you can have a Zoom call. All of that happens on a CPU. Whereas a GPU is built to compute a lot of simple calculations simultaneously. And the reason why it's important for AI is because the latest brand of AI, which is generative AI, requires a lot of simple calculations to happen over a short period of time. Right? That's why those things become very important. Right? Now, if you look at the total compute capacity that has gone on in the world of AI, x-axis here is time, y-axis here is the total compute required to build any model. Each dot is one model, right? There's two regimes going on, and then there's the third regime that most of you would be familiar with, which is Moore's law, which pretty much has kept technology world going for a long time. So roughly about 18 months, the total compute capacity doubles. That's the bottommost curve. The world of AI, since about 2011, has been going much faster than that, predominantly driven by accelerated computing. That's all the blue dots that you see there, right? And something happened in 2017, which was the introduction of this new piece of technology called transformers that changed the curve completely. It allowed people to build a different class of models that all of us today talk about called large language models. ChatGPT is a type of large language model. You can see that curve goes much, much faster. Every single one of those models were built on accelerators. Right? What is the impact of that on the world's compute is really what we'll see in a short while. But because of that compute increase, you can see an impact across every single technological domain. Today, I don't think there is a single domain that's not touched by this brand of AI, right? Now, how has the world of computing changed because this brand of AI was introduced? Now, if you look at the amount of compute that used to run on CPUs and the amount of compute that ran on non-CPUs. So think of accelerators that ran simple compute versus CPU that runs more complex compute. This is how the ratio used to look like about 5 years ago. Today, it looks like that, where the amount of workloads that actually run on a CPU that are AI based are shrinking rapidly, and the number of GPUs that you start seeing per system is also increasing rapidly because most of the workloads require a lot more of this, right? Now, one measure of looking at this is the world's fastest supercomputers. So every year, twice a year, the list of top 500 supercomputers are actually listed, and this is from 2018 Q2 to 23 Q2. So just 5 years. On the left-handmost side, you can see 80 4% of the systems were computing on CPUs. Today, that's less than half. Okay, that is from Q3 2022. Q2 23, Q4, that number has gone below 40%. So most of the top 100 supercomputers in the world actually compute on the GPU. In fact, there is a prediction out there that says in the next 5 years, there's going to be less than 5% of the data centers commissioned anywhere in the world that would not have a GPU. Whereas just 5 years ago, less than 5% of the data centers in the world had a GPU. So massive shift in terms of what's going on across the world, whichever geography you go to, right? And the reason that's happening is because of the rapid rise of applications, of course, but one size doesn't really quite fit all, okay? Just like how we talk about model sizes, and I'll come to that in just a bit, most of the examples I showed you are on the high end of the side, right? So whatever you're looking at from the perspective of training a model in terms of teaching it to do something, or after you train the model, you then ask it to predict something. So the training is done. Now you just ask it a question, it is asking you to respond. That's training versus inference. Across the board, you can train very large models with a group of computers all working together. Sometimes they refer to almost like a planetary scale compute. So ChatGPT, for example, was trained on north of 20,000 GPUs. So GPT-3 was trained on 16,000. GPT-4 is rumored to be trained on about 24,000. Right? We talked about flops in the beginning. So one flop is one floating point operation per second. Now, one exaflop is 1 billion floating point operations per second. Just to put it in context, imagine a billion people holding a billion calculators each, and all of them press the equal to sign at exactly the same second. They would have collectively done one exaflop of compute. GPT-4 is rumored to have taken 318,000 exaflops of compute to train. Just one model, right? That is the right side most end of the spectrum. Whereas once you train it, then the same size of the model then gets broken down. You can have smaller models, you can have larger models. You can have a spectrum of different hardware that actually is needed to go deployed into production. So it's not, again, any one size fits all. And the other thing that's also happening is the split between CPUs and GPUs are not necessarily as clean anymore. CPUs have accelerators inbuilt into them, and GPUs are starting to get CPUs inbuilt into them. So you are starting to see hybrid architectures evolve as well, just for exactly this thing. In fact, any one of you having a mobile phone today most likely have a CPU integrated with a GPU on it already, right? Now, I also want to talk a little bit, just a few minutes, about trends, because lots have been spoken about trends here in this conference here. And if you look at what has happened to every one of these trends in the last about 30 years or so, the PC revolution, the internet revolution, the mobile revolution, the cloud, every single one that today is considered to be seminal came with its own quote, and I consciously didn't put who gave the quote, but then you can Google it. This came from the best minds of the time, right? The best and brightest. And all this shows is it's super hard to predict mega trends, okay? That's one. The second thing also, and I want to leave you with two questions here. In the world of Gen AI, are we facing a hype? Is this a fad? Is this going to go away? Or is this going to be just as seminal as every single one of these changes have been, or even more seminal? That's one. The other one is this whole divide of, in fact, there was a famous CEO who came from outside India, came to India, and he was asked, is India going to be able to build large models? And he famously said, well, you shouldn't even try. Is that going to go up there? Okay. And the other camp is also about, we may not necessarily have to go about fighting this battle of large models. We can actually do small models. The problem with that statement is we don't know what is large or what is small yet. We have not hit the point of diminishing returns. People start throwing more data, they're starting to throw more compute, the model continues to improve. So we still don't yet know where the tipping point is. So for us to say we will go after small models or large models is a bit premature, to be honest. Of course, you have to start small and then grow. And to do any kind of compute in this world, you need accelerators today, right? And I can say this openly, coming from a company that actually invented the CPU and make a business out of doing CPUs, accelerators is a reality. And where we put it, how we do it, is one question. And the other thing I also want to leave you with is today's world of getting to large language models, ChatGPT, innovation, has taken a particular path to summit. That's just a path. That doesn't mean that's the only path, or that doesn't even mean that's the optimal path. In fact, you can clearly argue that the amount of energy used to train any of these models, the amount of money spent in training any of these models, is absolutely unsustainable. In fact, if you compute the total amount of compute that is required to build any of these models, in 2022, the largest model to train on a single day exceeded the total compute capacity of the planet. Let me repeat that. If you wanted to train the largest model in 2022 in one day, all computers on the planet collectively could not do it if you could actually figure out a way to connect it. That's how big that model was. And we've since surpassed that. So obviously we train it for much longer. But then the power required to do it, is it sustainable? All of that has to change. More importantly, the price of these accelerators is ridiculous on one side. The lack of availability is absolutely unsustainable. Today, if you want to buy a high-end GPU, you pay, wait in a line with between 9 to 18 months before they'll maybe ship one to you. That has to change, which means there'll be new players who will come in with more accelerators, the price will come down, algorithmic changes will come in so that you actually consume less power. But that doesn't mean we change the summit. You still have to summit. You just have to find a different path to get there. And in fact, I'll leave you with that. Downgrading goals for lack of capacity or lack of resources really shouldn't be an option, especially when we are so early in the game. Okay, maybe it's a contrarian view in a conference, but I just want to leave you with that. I know my 10 minutes are up here, but thank you so much for your time.